rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night we see the moon and the stars. We are able to see the words and sentences printed on this page. How is seeing made possible? What makes things visible? Have you ever thought how we see various objects? You may say that eyes see the objects, but can you see an object in the dark? It means that eyes alone cannot see any object. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object or may have been reflected by it. You learned in class 7 that a polished or shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? Let us find out. Laws of
Okay, okay,
reflection.
just wait. So is it clear? This paragraph is very easy. That so it is not only the object that we need to see, but also there should be a source of light. If there is no
Yes,
source of
ma'am.
light, we are not able to see anything, although there are objects. So at night, if the room is totally closed, or if a room is doesn't have any windows, and you just shut up the door, and it's totally dark, are you able to see anything inside? No.
No, ma'am.
So what is the priority? You should have a luminous object, or
Yes,
you should have a reflecting surface on which any other source is falling, and from that surface it is falling on any other object. So
yes,
we
ma'am.
need an, yes, Abhishek.
Ma'am, non-luminous objects reflects the light that are coming from luminous object, and ma'am, non-luminous object are also called illuminated object.
Yes, they get illuminated when the luminous light from the luminous objects falls on them. For
Yes,
example, moon. Naturally, the sunlight comes and just fall on the moon, and the
yes,
moon
ma'am.
gets illuminated, or the earths get illuminated, and the moon reflects that, as because it is an opaque object, it reflects the light, and we are able to see the moon at night. But
Yes,
still we are not able to see the moon in the daytime. Why? Because during
and
the
because of the
daytime,
bright light of sun.
yes, because of the bright light of the sun that is already there on the earth's surface, we are not able to see the illuminated moon. Okay, this much clear. So
Okay.
now
Yes,
we are
ma'am.
going to read on the laws of reflection. Now, yes, continue.
Yes,
Yes,
ma'am.
Jiguri.
Laws of reflection. Activity 16.1. Fix a white sheet of paper on a drawing board or a table. Take a comb and close all its openings except one in the middle. You can see a strip of black paper for this purpose. Hold the comb perpendicular to the sheet of paper. Throw light from a torch through the opening of the comb from one side. With slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Can you keep the comb and the torch steady? Place a strip of plain mirror in the path of the light ray. Figure 16.1. What do you observe? After shrinking the mirror, the ray of light is reflected in the other direction. The light ray which strikes any surface is called the incident ray. The ray that comes back from the surface after reflection is known as reflected ray.
Okay, now stop. Yes, so we are just recapping that we have done the right ray, that is the light ray that is falling on the surface, that is called the incident ray on the that surface, that shiny opaque surface, and that is getting reflected, or that is getting bounced back. Okay, not, you should not say reflected, because we are, if we are defining reflected ray, the word reflected we should not be there in the definition. So
Yes,
the ray after incidence that is just getting bounced back is called the reflected ray. Okay, now yes, Abhishek, continue from the next page. You will read the next page.
yes, ma'am. A ray of light is an idealization. In reality, we have a narrow beam of light, which is made up of several rays. For simplicity, we use the term ray for a narrow beam of light. Draw
So
lines,
what is it? What is it actually? Actually,
ma'am.
that we can see, those are
Ma'am, it's
not the
photons.
rays. Yes, they're collection of many rays falling, because rays are
Yes,
very,
ma'am.
very fine. So that collection is called the beam. So just for an idealization, we are going to write as rays or pronounce as rays, that are rays of light. Okay. Otherwise, it is not a single ray, but a collection of many rays with which we are doing the experiment, or that we are able to see. Yes.
Yes.
Now continue.
Draw lines showing the position of the plane mirror, the incident ray and the reflected ray on the paper with the help of your friend. Remove the mirror and the comb. Draw a line making an angle of 90 degree to the line representing the mirror at the point where the incident rays strike the mirror. The line is known as the
Yes,
normal
ma'am.
to the reflecting surface at that point.
So
The
you know, but you know that why it is called normal. I have explained it to you. It's not given over here, but I have told you what is normal. What is normal? Anyone can explain? What is normal?
Ma'am, the normal is there between the angle of incidence and angle of reflection. Ma'am, it divides the angle of reflection and angle of incidence into two equal parts, ma'am. And it is
Why?
the
Why?
perpendicular. It is the
Yes.
perpendicular, ma'am,
Why it is
from
called
the
normal?
surface.
Why it is called normal? Because if a ray of light is incident on any shiny surface at an angle of 90 degree, it will retrace its path. It will bounce back in the same path but in the opposite direction without any deflection. So that is why that line is called normal, that is perpendicular to the surface. So if there any ray is perpendicular, that is fall vertically on a surface, it will reflect back vertically. Hence that line is called normal. It is not anything ambiguous that normal has been taken 90 degree. No, 90 degree. Why it is taken? Any ray that is falling 90 degree will bounce back at 90 degree only. Am I clear, children?
Yes,
yes,
ma'am.
ma'am.
Yes. Now continue.
The angle between the normal and incident ray is called the angle of incidence. The angle between the normal and the reflected ray is known as the angle of reflection. Measure the angle of incidence and the angle of reflection. Repeat the activity several times by changing the angle of incidence. Enter the data in table 16.1. Do you see any relationship between the angle of incident and angle of reflection? Are
So
they
yes, just wait. So any change that you are seeing, if you take different angle of incidence and you take data of different angle of reflection, will there be any relationship between these two? Abdul
They will be
Kabir.
always equal.
yes, ma'am.
Just wait. I am asking others. Yes, if is there any similarity? Anyone other than Abhishek, Siddharth? Is there any similarity? Yes, we are going to find some similarity. Yes, Siddharth, what is that similarity?
Ma'am, these two angle will be always equal.
This two angle, that is the angle that the incident ray is making with the normal and the angle that the reflected ray is making with the normal will always be same, whatever may be the angle. So suppose there is a plane and a ray of light is falling at an angle of 45 degree with the making an angle of 45 degree with the normal. So it will reflect back also at an angle of 45 degree with a normal. If it is incident at an angle of 60 degree, then it will reflect back also at an angle of 60 degree. But in case when the angle when the incident ray is 90 degree, then what will happen? Without any
It will
deviation,
retrace
that
its
will
path.
reflect or retrace its path. Clear? So
Yes,
this is one law, that is angle of incidence is equals to angle
angle
of
of reflection.
reflection. Yes. Now continue, Siddharth.
Are they approximately equal? If the experiment is carried out carefully, it is seen that the angle of incidence is always equal to angle of reflection. This is one of the law of reflection. Let us perform another activity on reflection. What would happen if I threw the light on the mirror along the normal? Activity 16.2. Perform activity 16.1 again. This time, use a sheet of stiff paper or a chart paper. Let the sheet project a little beyond the edge of the table. Figure 16.4. Cut the proportion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extends to the projected proportion of the paper. Bend the part of the projected proportion on which the reflected ray falls. Can you still see the reflected ray? Bring the paper back to its original position. Can you see the reflected ray again? What do you infer? Incident ray, reflected ray, and the normal at the point of incidence lies in the same plane.
Yes. So is there a doubt, any doubt in figure 16.4? You can see it is showing the next law, that is the second law of reflection. What is it? That is the incident ray and the reflected ray and the normal lie on the same plane. That is the second law of reflection, and you can do it at home also with that active. No one is making any activity, children. Why are you not sending your activities? Just do send your activities, children. Okay. So is this clear? I think it is clear to all of you. This diagram is clear to all of you.
Yes,
Yes.
ma'am.
You can see that the same experiment we are taking, but in that case we are just, you can see first case that the incident ray and the reflected ray, we are reflected ray is extended back, and if you block the line you will see that we are not able to see the extended part of the reflected ray. So what is it concluding? It is concluding that the three of them lies on the same plane. Yes, Siddharth, now continue from the next, that is below 16.4, in the whole sheet.
Yes, ma'am. When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal, and the point of incidence and the reflected ray are all in this plane. When you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. What does it indicate? It indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This is another law of reflection.
Yes.
Paheli and Burjo performed the above activities outside the classroom with the sun as the source of light instead of torch. You too can use the sun as a source of light. These activities can also be performed by making use of ray streak apparatus available in the kit prepared by NCERT. Bujo remembered that in class 7th, he had studied some features of the image of an object formed by plane mirror. Paheli asked him to recall those features. First, was the image erect or upside down? Was
Stop,
it
stop, stop. So was the erect, we have already done. So now you're going to answer. Shobit, tell me, was the image that has been formed by the plane mirror is erect or upside down? Shobit?
Yes, ma'am.
Yes, ma'am, nahi, bolo answer.
हम क्या बोल रहे हैं